two others. Yep. You start here when you're in your late 30s or around about that time, and you think, good career, you know, just taper off when I get come in here and teach once a week or something, but that's all sort of gone. They don't kind of hire that many industry lecturers anymore now unless they really, really have to. She's one of the best teachers, yeah, oh, for sure, yeah. See, she ticks all the boxes. She does research. She also ticks the box for registration. She's a registered engineer, most of the people here are. And also, you know, she teaches a high level structure.
She is fighting for us as well, like with the exam. She's not doing the exam, but she doesn't agree with it. So she is fighting for us. But
yeah, if you work with her, you'll come out the other end knowing a lot more. But if you work against her, you know, it's probably not worth it.
That's the way do you think she will shout at you by time, and now she answer your question, tell you all the things?
Yeah. Okay, so today we're going to cover quantities, that kind of area, and the reason for it is, assuming this pen works. I've got another one in my bag. Yeah, that's good. The reason for it is that with our platform, here's our platform here. And I think the cut area is sort of going to come around here like this, and then the fill is going to start sort of heading down towards what is the wetlands. And of course this tree is going to come into play somewhere down here too. At the moment, if you haven't done it yet, which most of you haven't, you're not quite sure what's going to happen there, but this will probably confirm it once you've done your offset lines and joined them up with the ground lines to form the butterfly wings, right? So turning it around a bit, what I want you to do, the actual volumes of is, actually that's not right, is the fill's always the bigger area, is I'm going to get you to do a cross section through there where the cut equals 0 and the fill equals 0, and it looks like that. The next cross section is going to be through here where it cuts out of the platform. Next one will be on the platform. That one there you don't have to, you're going to do for your assignment. Number 4. Number 5 through the platform over here. Number 6 through the cut and the fill. And number 7 is just touching out the outside. So number 7 will be like that too. Which means, yep.
do we choose those gaps, or do we have a specific?
No, the gap will be totally you. So that, because you're choosing different gaps each, your volumes will be a little bit different. Also your contours are a little bit different. So it won't be like miles different. It might be 0.5 of a metre difference or a couple of metres. But believe me, there are little differences, so that's good. That means that you can ask your classmates, so what did you get? You tell them, and you go, oh yeah, it's pretty close. I think we've probably got it right. Or, uh-oh, one of us has got it wrong. Which is generally the case when I was studying. Right, so that actually made you go back in and dive deeper into it to get it right. Sometimes you're both wrong. So what do these look like? Well, you already know that number 4 looks sort of something like that, with the platform and the cut and the fill. And number 3 also will look something like that as well. So they're pretty easy to draw up. We drew them up last week. I'm not going to show you how to do that. Just make sure that when you do the cross section, that becomes your 0 when you're doing the lines up, right? Don't always go from the centre. The 2 that are going to be hard to do will be number 3 and number 6. And basically number 3 and number 6 are going to look something like this. And up here like that, which seems kind of odd, but that's just the way it is. That level there is going to be equal to wherever you strike this through. So that's why I'm suggesting strike it through a contour. If that's you know how the contours, the design contours come off the platform. If you remember back to week 2, we offset and offset and offset. We offset over here as well. Well, there'll be contours here and contours there. If you can make a line that goes through 2 lots of contours, then those little triangles will fall exactly on a contour. And of course, the contour goes along and then round the corner. So that point at which it goes around the corner is that point there. And same with this one, if it goes along and then around the corner, that point there is that point there. And that angle, that's easy. That's 2 to 1. And that's 1 to 1. Now, I can't do any more than that. I don't normally do that. I make students work that out themselves normally. But I'm giving you a tip as to the fact that 3 and 6 are the difficult ones to draw. So they'll be in here as sort of something like that. They have to be taken into consideration because of the prismoidal calculation sheet, which I'll talk about in a minute. So for your assignment, for assignment 2, I don't need to see where these go through. I don't need to see that in a viewport or that. I will need to see that in a proposed plan viewport. Sorry guys, I'm see my bum. Yeah, so you won't need to necessarily see that. But beside this, I want you to do your little cross sections. Above each one, I want you to put the area of cut and fill. So that might be 0.01, that might be 0.14, that might be 2.13, that might be 1.65, etc. So put the number. You know how to do that from AutoCAD with Ingrid. You draw a P line around here, and that gives you an area.
Oh,
so these are little areas, all right? They're not quantities yet, they're areas. So how do we do quantities? Well, I'm going to put Lucia's hat on right now. I'm going to teach you something about maths. In fact, you're all going to go, we already knew that. Okay. All right, so how do you find the quantity of that if I can give you area 1 and area 2 and D1? So this is going way back to primary school, really. A1 plus A2 divided by 2 times D1 equals your area. So if you had a box that was 3 by 2 by 4, you'd multiply 3 by 2 by 4, right? But if the box wasn't even and this side here was a different size, you have to average out the A's, the A1s, right? So if you had a series of boxes all the way along the road, and you had another area over here, you would then have something like, on top of that, you go plus A2 plus A3, averaged out, times, and of course that would be D2. Right? So that would carry on, say, along the road or along, in this case, along the platform. The issue with that is that is a little bit basic to mathematics. We're talking about a box. I mean, not all roads and platforms are kind of box shaped. A lot of this, here, look at this, that's not a box shape. It's kind of a funny shape, cut and fill. Then it merges into another cut and fill and another cut and fill, and then a funny little shape here, and then nothing at the end. So at the end it's like a wedge. Alright? So we have things called prisms and wedges that aren't taken into consideration with Roger's basic maths. So hence what was happening on site sort of in the 1930s, 40s, 50s, 60s is there was gross miscalculations of earthworks.